Okay, so now let's start combining derivative rules in more interesting ways now that we have the basics of the chain rule down. So, we have this lovely example here, and the very first thing that I notice is that to find the derivative we would need the product rule. So if we call this f and this g, then dy dx would have to be f prime g plus f g prime for the product rule, which is all fine and dandy, except that both of these are actually the chain rule as well. So let's do f as blue. So u here would be 3x, and then we would have f as e to the u. So f prime would be u prime times f prime. So that would be e to the u, which actually makes perfect sense because we've done this before in previous sections, and you may have just taken my word for it that that was how the derivative of e to the x worked. But this is why. They were using u substitution. They just hadn't told you what it was yet. So for g, once again, we're going to need the chain rule. So if u this time is 3x minus 2, then g prime, just g, would be u to the 8th, and g prime would be thus 8u to the 7th times u prime. So that would be 3x minus 2 to the 7th times the derivative of u, which would be just 3. So that would give us 24. 3x minus 2 to the 7th, 8 times 3 being 24. So now we can actually find dy dx. Sometimes this can definitely be interesting. So f prime times g plus f g prime and simplify as much as possible. So let's see here. Can't do much, but if we really wanted to, we could find the GCF, which would be 3e to the 3x times 3x minus 2 to the 7th. And then that would give us 3x minus 2 left, plus 24 divided by 3, which would be 8. Combine like terms, so that would give us 3x plus 6, and hey, we can actually pull out another GCF of 3 from there, so that would give us x plus 2, pull out the 3 and multiply it to the 3 in front, so that would give us 9 e to the 3x times 3x minus 2 to the 7th, and then times x plus 2. So do be careful. You can have a lot, but one step at a time. One step at a time. If you try to do too much too fast, it's the fastest way to get a headache in math class, trying to do math in your head. Okay, so that was the product rule. How about one with the quotient rule? So in this case, we would have the u of the middle, right? and then we would want u prime, which would be the quotient rule. So let's do this. So u would be 5t squared over 3t squared plus 2, and then u prime, quotient rule, that's f prime g minus fg prime over g squared. Okay, so f prime would be 10t times g plus f g prime, which would just be 6t, no? And then over g squared. Do that for a second, and then simplify as much as we can. So that'd be 30t cubed plus 20t plus 30t cubed. I did something wrong. Oh, minus. Minus in the formula for quotient, that's a minus, over g squared. So that would give us 20t over 3t squared plus 2 squared. So there's u prime. Okay. So for our derivative, dz of dt, we need dz of du times du of dt. So, otherwise known as z prime and u prime. So let's see here. So z prime would be 3u squared times du dt. So that's u prime. And I have a feeling we're going to have a lot of simplification on this one. So, let's see here. We got 3, and then u is our gigantic one. So 3, and then squared times 20t over 3t squared plus 2 squared. Okay. Right. Well, not as much a simplification as I thought, because it's all multiplication. Now, if it was division, we could definitely cancel some things out, but since it's multiplication, there's just not much we can do, except to go ahead and take care of that lovely square, the top one. So let's see, that'd be 3 times 25t to the 4th times 20t over 3t squared plus 2 to the 4th, and then multiply across. So we would have 3 times 25 times 20, which would be 1500 t to the 5th over that lovely 3t squared plus 2 to the 4th. So do be careful. I definitely first thought that we would be simplifying way more than we were, because I had it in my head that that was a division that we could simplify that way, but we can't because it's all multiplication. Okay, so let's have a what-if scenario. What if we had more than one composition at a time? What if we had 3 compositions all in a row, h of inside g inside f? So how could we find the derivative anyway? Well, we would use u substitution. We would just do it twice. So in this case, how about we would say that u would be h of x, which would give us du of dx, and then that would give us as, well, we'd need another one, wouldn't we? Because we would have g of u, which is fine, but we would still have the f, right? So we need another variable. So let's say v. So that would be dv du. And then that would give us as f of v, right? So that would be, and that f is finally at the outside. So we could call that y. So that would give us dy dv. So then we could have, multiplying all together, dy dx as dy dv times dv du times du dx. So if you have multiple compositions all in a row, that's fine. We would just have to stack them. So let's actually apply this. We have cosine of to the 9th power of sine of 16 e to the x. That's a lot. By my count, that's actually 4, in fact. Not 3, but 4. Now why? Well, you see the 16e to the x, that could be u, and then the sine part, sine of u, we could say as v, and we have the cosine, we could call that w, but that 9 would be outside, so that would be our y. So let's write this. Let's see here. So we would have y part for, so that would be w to the 9th for y. Okay, so then y itself, excuse me, not y, but w would be the cosine of v, yep, and then v would be the sine of u, and u would be the 16e to the x. So for our derivative, dy dx, we would need, what would we need? We would need dy dw times dw dv times dv du times du dx. And we would just link them all. So you can stack them. You can stack them just fine. So let's see here. dy dw would be 9w to the 8th times dw dv. So the derivative of cosine is negative sine of v. And then dv du, derivative of sine is cosine. And you may start to be very thankful that I use color coding so much. And then du dx, 16 e to the x would just be 16 e to the x again. Okay, so let's see here. So, right, that'd be the cosine of 16 e to the x and negative sine of v, which is sine of u. Oh goodness. Yeah, this is not going to get any prettier. So 9 times 16 is 144 and a negative, and we have the cosine to the 8th power of sine of 16 e to the x, double parenthesis, be careful there, and then we have sine of 16 e to the x, and then cosine of 16 e to the x. Wow! Make sure when you're putting it into the computer that you have all your parentheses in the correct places and you string it all together. Your computer should not care what's in front of what or what's being multiplied to what. It's just what is inside the other. So you shouldn't care if the cosine 8 is written first or second, but just make sure that it says cosine 8 of sine of 16 e to the x. Blah.